Okay guys, so for our last problem, problem number 6, so basahin ulit natin. An upstream reservoir contained by water with surface maintained at elevation 110 meter discharges water through a 1,500 millimeter diameter pipe on a downstream reservoir with water surface maintained at elevation of 65 meter. So a turbine is installed with the same level with the downstream reservoir. So pantay siya ng yung downstream reservoir. Determine the energy head extracted by the turbine as well as the power output if the flow rate in the pipe is 12 cubic meter per second. So the total head loss is 3 times the velocity head at the pipe and the efficiency of the turbine is 69%. So again, i-drawing muna natin yung figure para mas madali natin ito ma-analyze. So magpalit lang ako ng pen. So kapag turbine, so this time this is a turbine problem. So meron ka ditong reservoir, upper reservoir. So alam natin na kapag reservoir, isang malaking container yan or isang malaking body of source of water. So wala rin naman sinabing enclosed siya. So ano mangyayari? So wala yung pressure head at the same time yung velocity head will also be zero. So drawing ko muna ulit. So meron siyang pipe dito and then yung downstream niya pantay na lang yan. So, papasok siya sa isang turbine. So, lagyan natin dito turbine. And then, yung level ng turbine is with the same level of the lower reservoir. Ay, pantay nga pala. Sorry. Ayan. So, ang elevation dito, ayan. So, water surface level. So, pangalanan natin to as 0.1. So, magpalit lang ulit ako. So, this is 0.1 and this is 0.2. Again, the velocity and the pressure head at both elevation reference 1 and reference 2 or the datum for datum 1 and datum 2 is the same. So, ito yung ating upstream reservoir. Ito yung higher point na reservoir. So, this is the upstream reservoir. And ito yung magiging downstream reservoir. Downstream. Okay, so again, as I've said, the velocity head here will be equals to 0. At the same time, yung pressure head niya will also be equals to 0. So, ang natira na lang dito is yung elevation head kung saan yung elevation head na 0.1 is given as 110 meter. And at 0.2, so the velocity head here is the same as velocity 1, also equals to 0. At the same time, yung pressure head. So, ang elevation ng ating reservoir 2 is the same elevation as the turbine with an elevation of asaan siya? Ito, 65 meters. Alright, so ano pa bang kailangan natin malaman dito? So, we have the discharge or the flow rate in the pipe. So, yung flow rate na tumatakbo dito is given as 12 cubic meter per second. So, sinabi na ba na may kaiba yung diameter niya? Okay, so iisa naman yung diameter. So, isolve na natin yung velocity niya. So, the velocity of this will be equals lang sa Q over A, or that will be 12 cubic meter per second divided by pi over 4 times the area. So, times the diameter squared. So, that is 1.5 meter. So, kinonvert ko na siya directly. 1.5 squared. Or the velocity will be equals lang sa, so pinutin lang natin guys, 12 times 4 divided by pi divided by 1.5 squared. So the velocity there is 6.79. 6.7906 meter per second. So okay, so apply na tayo ng Bernoulli's energy equation. So again, ang sabi ko nga, maximize nyo kung saan points maraming ma-eliminate. So ang gagawin natin, apply BEE from point 1 to point 2. Okay, so from this point up to this point. So that will be the total energy at point 1 plus or minus the summation of the head loss. So from point 1 to point 2. And then, so ano nga kapag heat extracted? So minus heat extracted. Okay, so tandaan lang. Ayan. So equals to the total energy at point 2. So again, velocity head. So ano na lang natira dito? Yung elevation head niya na 110 meter. So minus the velocity head from point 1 to point 2. So nabasa na natin kanina ito. Yan, ito. So the total head loss is 3 times the velocity head at the pipe. So 3 times the velocity head. So 3 times the velocity head, or that will be 6.7906 squared all over 19.62. Ayan lang. So ganyan lang yung head loss. So sabi nga, 3 times the velocity head. So 3 times the velocity head, which is this one. So minus the heat extracted is equals to the elevation at point 2, which is 65 meters. So with this, makahanap natin yung heat extracted niya. And then ano nga yung ating kapag power sa isang turbine. So diba ang power na ma-compute natin dito is yung power ng input, kasi yung tubig is o yung hydraulic energy is yung pumapasok dito sa turbine. And yung lumalabas dito is sa turbine is the electrical energy. So the power input, so later on, hanapin muna natin yung heat extracted. So 65 minus 110. Pinito lang sa calculus, 65 minus 110 plus 3 times 6.7906 squared divided by 19.6. So the answer is positive, ano nakuha na? So positive 37.9492 meter. Okay, so once na meron na tayong heat extracted, we can now compute for the input power. So to solve that is equals lang sa Q gamma of the heat extracted. From where yung Q is given na 12 cubic meter per second, so 12 times 9.81 multiplied by 37.9492 times 12 times 9.81. So our answer is 4,467.3795. So this is kilonewton. This is kilo watts. So ano ba pinapahanap? Determine the energy heat extracted by the turbine as well as the power out. So the total energy heat extracted, so ito yan. So meron na tayong sagot sa isa. And the output. So para makuha yung output, so since given naman yung efficiency ng inyong turbine, so again, ang efficiency has an equation of P out over P in and then times 100. So to solve for P out, so that is equals lang sa P in na 4,467.3795 and then multiply by 69 over 1,000. So the power output for this one is times 69 divided by 1. So that is 3,082.4919. So again, if the final answer is required to be horsepower, so just convert that in horsepower. Pero ibaksan natin to. So ito yung hinahanap sa pangalawang tanong. Okay guys, so that ends our discussion for the flow rate and yung application ng Bernoulli's energy equation. So let's proceed with the next topic.